All right, college algebra, we're looking at functions today, section 2.3. First of all, let's just look at ordered pairs and relations. Here's a relation right here, and I've already wrote it down. We've got 8 paired up with 9, we've got 2 paired up with 7, and we have 11 paired up with 15. Okay, now the first numbers are my x's, and my second numbers are my y's. Okay, we have what's called domain and range. Domain and range. And what I've always taught and remembered this, I went to the doctor to get an x-ray. And domain is your x's, range is your y's. So this is an easy way to remember domain and range, because some people get them mixed up. Now, in this relation right here, what is my domain? All right, my domain, well, I've got an 8 right in this first order pair. I've got a 2 there, and I've got an 11 here. This is my domain. Now, a lot of times it don't really matter, but I put them in order. That's my domain. My range, 9, 7, and 15. So 7, 9, and 15. This would be my range. Okay, but domain is your x's, range is your y's, and this is a relation and how x and y are related for some reason. I don't know. This could be 8 people went to the dance, and there was 9 hot dogs they ate. I don't know. Here, 2 people went to the dance and they ate 7 hot dogs. I don't know. It could be any kind of relation how these numbers are related. You know, whatever. Here's number 2. Determine the range of this relation. All right, the range, well, we got an 8, we got a 9, we got a 10. 8, 9, and 10. They put them out of order for some reason. I don't know. But now, a function, all right, a function is a relation where each x is paired with only one y value. Each x is paired with only one y value. So if you look at this right here, this is a function. Because see, you have 8 paired up with 9, and 8's not paired up to anything else. 2 is paired up to 7, and I don't see 2 paired up with anything else. And then 11 is paired up only with 15. So this is a function. Here's one here. 5 is paired up with 2, 3 and 7, 4 and 6, 5 and 8. Okay? This is relation here, but this is not a function. Why is it not? Because right here, 5 is paired up with 2. And over here, we got 5 paired up with 8. We can't have 2 y values with 1 x value. So this is not a function. This one's not. Okay, here's another one. 3 paired up with 6. 2 paired up with -1. 4 paired up with 6. 5 is paired up with 7. Okay. This one here, this is a function. Now, some people get mixed up with this right here. We got 3 paired up with 6. We got 4 paired up with 6, which that's okay. We could have 2 x values paired up to 1 y value. We just can't have 2 y values paired up to 1 x value. So this is a function. This one is a function. Because 3 is paired up with 6, and I do not see 3 paired up to anything else. 2 is paired up to -1, nothing else. 4 is paired up to only 6. 5 is paired up only with 7. So this is a little bit about what a function is. All right, now if you have an equation, like right here, y equals 2x minus 7. Okay, this is an equation. This is a function. So what we can do is we can write it like this. We can do the function of x instead of y. And we can write it this way. and it's a function. And a function is a little more special than just any regular relation. And it's sort of like an upper scale equation, maybe. Anyway, so this is what a function is. We write it function of x, like this right here. So here we have number 3. We have function of x is negative 2x plus 9. What is function value of negative 6? So when I have function of x equals negative 2x plus 9, what's the function value of negative 6? Well, I'm going to put negative 6 in for x over here. So it's going to be like this right here. So just put the negative 6 in, and then I work this out. So negative 2 times negative 6 would be 12. 12 plus 9 would be 21. So the answer should be 21. Okay. On this one here, number 4. For the function of x equals radical x, find the function value of 144. So I'm just going to put 144 in for x up here. So it's going to be this right here. And the square root of 144 is 12. So my answer is 12. Okay. All right, determine if this is a function right here. All right. Is this a function? So you look at your x values. That's what you're concerned about. So I see 7 paired up with 5. Do you see 7 paired up with anything else besides 5? No. Negative 4 is paired up with negative 5. Is negative 4 paired up with anything else? No. 2 is paired up only with negative 2. 5 is paired up only with negative 8. So yes, this is a function. Is 6 a function? 5 is paired up with 2. I don't see 5 paired up with anything else. 3 is paired up with 2. Oh, 3 is paired up with 3. This is not a function because we have 3 paired up with 2 different y values. The first two, 5 being paired up with 2 and 3 being paired up with 2, that would be okay. But this is what makes it not a function right here. Number 7, determine whether the relation is a function. Okay, we've got this little table over here. We see our x values and our y values. All right, well, 4 is paired up with negative 6. 6 is paired up with negative 6. 11 is paired up with negative 6. But this is okay to have repeats on y's. We can't have repeats on x's. So 4 is only with 6, negative 6. 6 is only with negative 6. 11 is only with negative 6. So yes, this is a function. Okay. What about 8 here? Is 8 a function? So let's look at it here. Well, first this is asking for the domain range. So let's. All right. So my domain 13, 21, 35, 13 again. So we don't write it but one time. 56. All right. So I'm gonna put these in order. So it looks like 13 would have been first, and then let's see, 21 would be next. And then 35, and then 56. These are my x values, so that's my domain. Okay, now my range is the y value. So I got 5, negative 7, 5, 6, and 6. So negative 7 would be first. And then I've got 5, and it's on there twice. And then I've got 6, and it's on there twice. So there you go. It's negative 7, 5, and 6. So you can see there's my domain, and there's my range. Now, see, it's already got the braces, so you don't have to put those in there. You just have to put the numbers in. Now, is this a function? All right, if you look at the relation again, this is not a function. Why is it not a function? Right here, I got 13 paired up with 5, and then I have 13 again paired up with a different number, 6. Can't have that. That's not a function, so no. It's not a function. Okay. Now, determine if this relation is a function. Now, this is what's called a mapping. And you see 1 is paired up with 6, 20 is paired up with 2, and 12 is paired up with 6. Now, basically what you have going on is just these ordered pairs. We got 1 paired up with 6, 20 paired up with 2, 12 paired up with 6. So this is basically what you have if you look at ordered pairs. Is this a function? Yes, this is a function. So you see it down here, yes. Because 1 is only paired up with 6. 20 is only paired up with 2. 12 is only paired up with 6. So yes, it is a function. Now, if you have a mapping, here, I'll make up one that's not a function so you can see. 1, 20, and 12. Let's do 6 and 2. And I'm just going to change this up a little bit. Now, this would not be a function. Why? Because right here, 1 is paired up to 6 and to 2. This would not be a function if I had that. Okay. Now, down here, mappings are easy to tell what your domain and range is, because in this circle right here, these are your domain numbers, and in that circle, those are your range numbers. So my domain right there, 1, 20, and 12. And my range right there is 6 and 2. So that makes it easy to find your domain and range when it's like a mapping. Okay, decide whether this relation defined by the graph is a function. Okay, now, when you have a graph, what you got to do is you got to employ what's called the vertical line test. What the vertical line test is if you can draw a vertical line anywhere and touch it twice, it's not a function. Well, this one here, it's okay. It is a function. So yes, it is a function. Let's look at some other ones that might not be. What about this one? This is a parabola. Can we draw a vertical line anywhere and touch it twice? So here we go. If I draw vertical lines, I will only touch it one time. Now it gets kind of close right here, but it's actually going out. So yes, this would be a function. Okay. What if I did the same graph and did it this way? Okay, well look here. Now as soon as I do that, I see it's not a function. So if you can draw a vertical line and touch it twice, it's not a function. That's called the vertical line test. Okay, what about a circle? We just talked about circles in the previous section. Look, it's not a function. Okay, so the vertical line test will tell you if it's a function or not. And this is a function. All right, now it's asking for the domain and the range. All right, the domain, remember, went to the doctor and I got an x-ray. Domain is your x's, range is your y's. So if you look at this graph here, what x values do we have? What's the furthest to the left? You know, we do this in interval notation. What's the furthest to the left that this graph goes? What's the furthest to the right that this graph goes? So if you look how this graph goes up and up and up and up, it's going over. What's the furthest to the left it goes? Well, see this arrow? That means it goes forever. So as it keeps going and going and going, it's going to the left forever. So that means my domain is going to be negative infinity. Now, what's the furthest to the right that it goes? Well, you see this thing as it goes, it's got this little arrow here, which means it goes forever like this, which means it's going to the right forever. So here's my domain. It goes from negative infinity to positive infinity. There's no end. What about my range? Well, it's the same thing. As this thing travels this way, it's going up forever. And as it travels this way, it's going down forever. So it goes from negative infinity to positive infinity. Remember now, on your intervals, you always have low, and then you have high. You have your low value, and you have your high value. And so that's what my domain and range is here. Okay. Number 11, decide whether this is a function. All right, we just did this. Look here, I draw a vertical line and touch it twice. It's not a function, so no. Now, what's the domain and range? Okay, well, if you look at your domain, that's your x's. Sideways, what's the furthest to the left that it goes? Well, if you look at this graph, the furthest to the left it goes is right here, -5. And we do consider that including -5 because it curves around through there, so we do count -5. Now, what's the furthest to the right that it goes? Well, see this arrow right here? This arrow, it's going to go that way forever. So it's going to go to infinity. And we never do reach that, so it's always a parentheses. So that would be my domain right there. Okay? And what about my range? All right. What's the furthest down that it goes? Range is your y's, which is up and down. So as this thing goes down here, see the arrow? It's going to keep going, and it's going to go down and down and down, so it goes down forever. So that's going to be negative infinity. What's the furthest up that it goes? Well, as this thing goes this way, it's going up and up, and it's going to go forever. So that would be my range. So you see our answer over here. That would be my domain and range. Okay, decide whether this one is a function. Well, if I draw a vertical line anywhere, I will not hit it but one time. So yes, this is a function. You can only touch it one time. So yes, it's a function. All right, now what's my domain and what's my range here? All right, my domain, what's the furthest to the left? Remember now, domain is your x's, and they go left and right. So what's the furthest to the left that it goes? Well, this arrow, it's going this way, so it's going over forever. To the right, all right, as we go to the right here, it's got this arrow, which means it's going to go forever. So there's my domain. What about my range? All right, remember it's always low, high. So the lowest it goes, the furthest down, it goes negative infinity. What's the highest it goes? It's positive infinity. Now low and high, this is also considered low and high, which is left and right. Okay, just want to kind of clear that up. So that's my domain and range there. Okay. Now, let's look at this right here, equations. Here we have an equation, and it's asking us if that's a function. All right, how do you know if an equation is a function? All right, here's a couple things that it's easier to tell what's not a function. If you have y in absolute value bars, that is not a function. If you have y squared or some even power, it's y squared or y to the fourth or y to the sixth, that's not a function. Okay? And there's others, but I think these are the only ones that we're going to really be concerned about. If you have y in absolute value or y squared or some even power, that's not a function. All right, well, right here we got y equals x to the 14th. Now this is x to the even power, not y to even power. So this is okay. This is a function. So you can see down here, yes, it is a function. Now, what's the domain on this? Okay. What can x be? So when you're doing the domain range and you got an equation, you just have to kind of think about what can x be here. So as I put x in, a value in for x, okay, I can put any value in there. So that means my domain is going to be negative infinity to positive infinity. But now when I put these values in there, like if I put a negative number, like negative 1 to the 14th power, all right, that's going to be a positive 1. So because this is an even power, it's not ever going to be negative. Now it can be 0. 0 to the 14th power would be 0. So for y can only be 0 or some positive value. So that would mean right here, from 0, that's the lowest y could be, and it does include 0, to infinity. Now that might be a little bit hard to understand, but if you have some questions about that, you can contact me. So here you go. Is this a function? Oh, look here. The equation is not a function if you have y in absolute value or if you have y to even power, and we have y to even power. So this is not a function. So this is no. Now, this is the same kind of thing as far as what we just did. As far as my domain, I can put anything in for y. So my domain, for my range, I can put anything in for y. So my range is going to be negative infinity to positive infinity, sort of like my domain for the previous problem. But now on x, see if I have y is negative 1 to the 10th power is going to be positive 1. So see, x is never going to be negative. Now x can be 0, but it's never going to be negative. So that would be my domain right here, 0 to infinity. And it does include 0. All right, decide if this is a function. Okay, well, I don't see y in absolute values, and I don't see y with the even exponent. So yes, this would be a function. So yes, it is. Now, what would be my domain and range? Well, if you consider the graph of this, this is 2x minus 3. This is a line. This is just a plain line. I've got negative 3, which is where it crosses, and the slope is 2 over 1. So it goes up 1 and up 2 and over 1 like this. So this is a line. And if I look at my vertical line test, I will only touch it one time. So yes, it is a function. And as far as the domain, this thing goes to the left forever and it goes to the right forever. So there'd be negative infinity to positive infinity. And as far as the range, it goes down forever, it goes up forever. So that would be my domain and range. So when you have a linear equation like this right here, that'll always be your domain and range. Okay, decide whether this is a function. All right, we've got x plus y is less than 7. Okay, now here this is not going to be a function because it's a less than. Anytime you have a less than, we have several values it could be. Like right here, look, let me show you this. If x is 2, y could be 3. 2 plus 3 is 5, which is less than 7. But if x is 2, y could also be 4. Because 2 plus 4 is less than 7. So see, there's different values I could have for y here with this same x value. So this is not a function. So just know, anytime you have an inequality, it's not ever going to be a function. Never will be. Now, what's the domain on this? Okay, well, x could be anything and y could be anything. So we're going to have our domain and range are both negative infinity to positive infinity. Okay. Now right here we've got some more of these. If f of x equals negative 3x plus 9. All right, what's f of 0? So I'm going to put 0 in for x. So I'm going to have negative 3 times 0 plus 9. Which negative 3 times 0 is 0, plus 9 would be 9. So my answer would be 9 on that. So some of these are, kind of easy. Okay, let's go to the next one here. 18. All right, this one here, g of x equals negative x squared plus 5x plus 3. All right, what's g of negative 2? All right, so I'm going to put negative 2 in for x. So now negative 2 will go there. Negative 2 will go there. And that's what you got. So what causes some people to mess up on this is this negative outside here. So we've got the negative outside, and then I'm putting parentheses and negative 2 in wherever x is. And then this you can just type in your calculator if you want to. You can just type it straight in. So as I do that, I've got negative, and then in parentheses, negative 2 squared plus 5, and then I got negative 2 in parentheses again, plus 3, and it comes out negative 11. Oh, I didn't put my equals in there. Should be negative 11. And that's right, yeah. Okay. So here's some more. We're just putting these values in. So on 19 here, find f of 1/2. So I'm just going to do f of x equals negative 6x plus 3. I'm going to put 1/2 in. Okay, so I just type this in. Negative 6 times 1/2 would be negative 3, plus 3 would be 0. Okay. Right here, we're just finding g of 1/2. So g of x is negative x squared plus 5x plus 4. So I'm going to do g of 1/2. So I'm just going to put 1/2 in for x. So it's going to be like this. And I just type that straight in. And it's going to be 25 over 4. Okay. All right, right here. Now on this one, look. Screwed up a little bit. F of x equals negative 2x plus 1. Now this says find f of negative x. So it means right there I'm going to put negative x in for x. So that means I'm going to have negative 2, and that right there where x is, I'm going to put negative x in. Well, negative 2 times negative x would be a positive 2x. And then I can't do anything more, so there you go. You can see my answer there. And then 22 is a similar thing. It says f of x is negative 5x plus 6. All right, what's f of x plus 3? Well, just like the previous problems, I'm going to put that in for x over here. So I've got negative 5. I'm going to put x plus 3 in for x. And then I'm going to have to distribute, so that's going to be negative 5 times x, which is negative 5x. Negative 5 times 3 is negative 15. I got plus 6, and then these two go together. They're like terms. So it's going to be negative 5x minus 9. Okay. All right, 23 here. We've got a relation here. Find f of 0. All right, now every time you have like f of 0, or well, what I'm doing there, f of 0. All right, this is my x. See, this is my x value right there. This is f of x. So this number inside here is the x value. This number over here you get is the y value. So like if I have f of 2 equals 7, all right, 2 is my x and 7 is my y. So this is an ordered pair we have for that. All right, this says find f of 0. So all I do is I look in the function here, and right there, 0 is my x. That means 5. This equals 5. Okay. In this problem, what's f of 1? Well, it's negative 7. What's f of negative 6? Well, it's 0. Okay. Right here on this mapping, what's f of 2? All right, so remember, this is my x values here. These are my y values over there. Here's 2, and that would be 2. And this one, what's f of 0? Well, that would be 4. What's f of 3? Well, that would be 9. Okay. Now we're going to have some problems like this. F of x equals 9. What is x? All right, f of x equals 9. This is my y value. So if I look at my y values, 9 right there, well, that means x must be 3. Okay, we'll have one like that in a minute. Might be jumping the gun. All right, here we go. We've got a graph over here now. Looking at this graph, what is f of negative 3? So this is my x value right here, negative 3. So I go to negative 3. All right, here's negative 3 right there. And that's my x value, negative 3. What's the y value there? Well, it's 0. The y value up and down is 0 there. Let's do another one here. That might be kind of hard to understand because it's on the axis there. But f of 0. All right, this is my x value. So here's my x value at 0. Now where's the function at? Well, it's way up here. It's at 6. What about f of 4? So if I go 4 on the x value, right here, here's 4. Where is it located on the function? Well, it's right there at 2. Okay, and then f of 6. This is my x value, 6. So if I go to x value of 6, where's the function located? It's up there at 6 for y. Okay. What about f of 5? What's f of 5 on here? So if I go to 5, here's 5 for the x. See, this is my x value in there. So if I go to 5 on the x value, where does it land on the y value? Well, it's going to be up here at 4. Okay. Here's another graph. Okay. So on this one, use the graph to find f of 2. So remember now, this is my x value inside there. So if I go to the x value of 2 right here, where's it located on the function for the y value? Well, it's right there. See, if I go up, there's the function, which is at 3. That'd be 3. Okay. There's several problems on here, but you know, a lot of them are easy ones like this. They don't take much time to do. All right, 27. An equation defines y as a function of x is given. Solve the equation for y in terms of x and replace y with the function notation. And then find f of 11. So right here we have this equation here. So let's get some paper. We got x plus 3y equals 12. All right, so solve the equation for y in terms of x. We need to solve for y, which means I'm going to have to subtract x on both sides. And x minus x will go away. So I'm just going to put 12 minus x. Okay. Now I'm solving for y, so it means this 3 I've got to divide by it to get rid of it. So this will cancel off. So I have y equals 12 minus x all divided by 3. I can't really divide that up. I could split it up, but I don't have to. You see, there's my answer right there. So I just leave it like that. Okay? Which means then I'd have f of x equals this. Which there's really my answer right there. See, it says f of x equals this right here. Now it says find f of 11. All right, so f of 11, I'm going to put 11 in for x, which means over here I'm going to have 12 minus 11 over 3. And right there where x is, I'm putting 11 in. Okay, well 12 minus 11 will be 1. 1 divided by 3 would just be 1/3. So there you go, 1/3. Okay. All right, here's another one. It says, here's an equation. Solve for y in terms of x and replace y with the function notation f of x. So I have, let's see here, y plus 2x squared equals 4 minus 4x. Okay. So I want to solve for y. So here's my only y right there. Here's my equals. I'm just going to minus 2x squared. That'll go away. So y equals, let's put this in order. Negative 2x squared minus 4x and then plus 4. Negative 2x squared first, the minus 4x, and then the plus 4. And so I can change that to function notation now. And there you go. There's my answer. And you can see down here, that's what yep. Okay. Now find f of 3. So I'm going to do f of 3, which means I'm going to put 3 in for x over here. So wherever x is, I'm going to put a 3 in. And then I just type this in. So you just type it straight in the calculator. Okay, so we'll do this real quick. Negative 2, 3 in parentheses squared minus 4 and 3 in parentheses plus 4. Negative 26. There you go, negative 26. Okay. All right, so then we get to this next thing. We have, it's asking for intervals which the function is increasing, decreasing, and constant. All right, increasing, write this down here. We have increasing, decreasing, and then constant. Okay, increasing, as x increases, y increases. Okay, that means if you look at a graph, it's real simple to look at. It does something like this. As x gets bigger, y gets bigger. So as you go over from left to right, it goes uphill. Decreasing, as x increases, y decreases. So as you look at a graph on it, it looks like this. As x gets bigger, y is going downhill. And then constant is this. As x increases, y stays the same. Which would be like this right here. So as x is increasing, the y value is staying the same every time. So this is really easy to look at on a graph. Increasing, as you go from left to right, it's going uphill. Decreasing, as you go left to right, it's going downhill. And then constant just is a straight, level, flat line or whatever. So on 30 here, state the intervals which it's increasing, decreasing, or constant. Okay, so when is it increasing first? Well, right here. It looks like from here to here, this is increasing, because as you go from left to right, it's going uphill. So where does this start? All right, you got to look at the x values of where it starts. And it's starting right here at -1. And it ends up right here at 3. So from -1 to 3, this is when it's increasing. Okay. Now, when is it decreasing? All right, decreasing right here. This is decreasing because as you go from left to right, it's going downhill. This part's going downhill. That's decreasing. Now, where does it start? Well, look at this arrow. It keeps going forever. So it starts -infinity. So from -infinity all the way out here, it comes and comes. It's going down, down, and down until it gets to right there at -1. And then at -1, it starts increasing. So this is the interval which it's decreasing. It starts at -infinity and goes all the way to -1 here. And then we have constant. When is this thing constant? Okay. Constant, well, you see right here, this is where it's constant, right here. Where does it start? It starts right there at 3. See the x value of 3? It starts being constant at 3. When does it end? Well, see this arrow? It goes forever to infinity. All right, so you see that's what our answers were down here. Okay. Now, increasing is when it's going uphill. Decreasing when it's going downhill. Constant when it stays the same. All right? And these never have brackets. They're always parentheses when you do increasing and decreasing and constant. All right, so here's another one. This is 31. Tell what intervals it's increasing, decreasing, and constant. Well, as I look at this, I don't see any constant. So there's not one of these. So it's never constant. Now, when is it increasing? All right, let's see here. This right here looks like it's increasing, right, to me. Because as you go from left to right, it's going uphill. Then this is decreasing. And right here again, now here's increasing again. And see, it's got arrows on it. It's got an arrow here. All right, so on this interval here, when does it start increasing for this one? Well, it goes forever So it goes to the left, negative infinity. And then to the right, it stops right there at, let's see here, what is this? 2, 4, 6, 8, 10, 12, 14. So this would be 2, 4, this would be 6, negative 6. Okay. And then comma, I got another one. This one starts increasing right here. There'd be 2, 4, there'd be positive 6. And then see, it goes and it's got this arrow, which means it goes forever. So that means it's going to go to the right forever. So it's going to start here and it's going to go this way forever. All right. Your intervals are always your x values. You always look at the x values for your intervals of increasing and decreasing. Okay. Now, oh, wait a minute now. I didn't see this okay. This point right here is -5. I just looked at it from here, thought it was negative. This should be -5. Okay. And I didn't notice this point right here. That is +5. I just thought I just counted over to 6, but I guess it's actually 5. So this should be 5. I didn't notice the points there, so you got to look at those. Made a mistake. Okay, so it goes from negative infinity to -5 for x. See, this is my x value, so it goes from negative infinity all the way down here to -5. And then it starts here at +5 and goes to infinity. Now, when is it decreasing? All right, from right here to right there, this is decreasing because it's going downhill. All right, what value does it start at? Well, it starts at -5. And when does it end? It starts -5 and it goes right here to +5. And that's when it's decreasing. Okay, and then it's never constant. Okay. All right, here's another one like that. When is this increasing, decreasing, constant? Well, again, this one's not ever constant. Now, when's it increasing? It looks like right here, this is going uphill. This is downhill. Here's uphill. And that's downhill again. So these two parts right here are increasing. Now, this one here, where does it start? Well, it's got this arrow, which means it goes to negative infinity, sideways. So negative infinity all the way to this value right here, -4. And then this one starts at -3. See that -3? It starts at -3 and then it goes and ends right here at -2. So that's the intervals on which it's increasing. Now, when's it decreasing? All right, decreasing is going downhill. All right, tell you what, let's do this in blue so you can see a little better. Right here and right here. Okay. These are going downhill. This one here, where does it start? It starts right here at -4. And then when does it end? It ends right there, which is at -3. So there's my interval, which it's decreasing for that piece. And then this piece, it starts right there at -2. And it goes down and see the arrow, which means it goes forever to infinity. So that's my decreasing. Here's my increasing. Here's my decreasing. And it's never constant. Okay. All right, now we get to some application problems. All right, so this graph shows megawatts of electricity used on one day in one city. So you can see the lowest it is right here. It looks like 3 o'clock in the morning. And then the highest, all right, here's noon right here. See, the highest is about right there, which is 1500, which is 3 o'clock in the afternoon. And then you can see it gradually comes down. This is how much electricity in a certain city is used each day. Is this a function? Well, I can draw a vertical line anywhere and never touch it but one time. So yes, this is a function. Okay, what's the domain? What's the furthest to the left? What's the furthest to the right? All right, well, that goes from 0 to 24. So my domain would be 0 to 24. And I don't know if we would include both of those. Let's see. Yeah, I think we would. Yeah. We're going to include both of those because it does include 0. I wasn't sure because 0 is 24. You know, this is midnight, and that's midnight also, but it does include both of them. Okay. Then we're looking at some applications here like C. Estimate the number of megawatts used at 7 a.m. All right, so if we go 4, 5, 6, here's 7 a.m. right here. We go up, and it looks like it's right there at 1200. So this looks like 1200. Okay. Now, part D. At which hour, 0 through 24, was the most electricity used? All right, we already did that up here at the top, right there. We said that was 15, didn't we? Yeah, 15. So 15 hour. Okay. Checking my answers here. We're good so far. Okay. There's my answers on this next page. All right. Now, at which hour, 0 through 24, was the least electricity used? All right, the least is right here at 3 o'clock in the morning. So the third hour. That's when the least electricity is used. Okay. All right, what about part E here? Call this function f. What is f of 12? All right, f of 12, here's 12. So I go up here. Okay, I lost track. It's going to be right there, it looks like, at 2200. 2200. Let's check, make sure we got that right. It says 2150. Well, at 12, yeah, maybe right there, kind of. The light's really bright. It's hard for me to see exactly, but I think it is 2150. Now, I'm thinking you can expand this on your picture on your screen. I'm not really sure. All right, interpret the answer in this context. So I think this is the last one, I believe. No, I think there's a couple more. All right, so let's look at it here. I have to take the picture off the screen, put it back. The value represents the power used by all electric consumers in this city at 12 noon. Interpret the answer here in this part E. Okay, I'm not understanding. I understand it now. F of 12 is 2150. Now, what does F of 12 mean? Okay, I think that's what it is right there, A. It's the value that represents the power used by all electric consumers in the city at 12 noon. See, at 12 noon, that's how much electricity is used in that city at that time. Okay, let's go to the next one here. So I'm going to have to, there we go. Now, during what time intervals did electricity usage decrease? Note that 15 hours is equivalent to 3 p.m. All right, so when did it decrease? Okay, it's decreasing right here from 0 to 3, and it's decreasing right here from 15 to 24. Okay, which I think this will connect over here and it'll do the same thing the next day, I would say. And so let's see here. During what time interval did the electricity usage decrease? So the electricity usage decreased from midnight to 3 a.m. and from 3 p.m. to midnight. No, I don't think that's right. No, I believe that's right. Electricity usage decreased from midnight to 3 a.m. Wait a minute. This might have been right. A. The electricity usage decreased from midnight to 3 a.m. and then from 3 p.m. to midnight. So yes, this was right. I was thinking of increasing there for a minute, but we're decreasing. So yeah, from midnight to 3 a.m. and then from 3 p.m. to midnight. So the A would be the answer there. Okay. And then the last one here. During what time interval did electricity usage increase? All right, it increased starting right here, and it's up to here. This is increasing. See, it's going uphill. That started at 3 a.m., and it ended at, what did we say this was? 3 p.m.? So 3 a.m. to 3 p.m. All right, so I think right here. The electricity usage increased from 3 a.m. to 3 p.m. So that would be my answer there. All right. I think this is the last one, which is a similar type problem. Let's see if I can't butcher this one up. Okay. So given the graph shows temperatures on a given day in town A. So this is the temperature. Okay. At what times during the day was the temperature over 50? All right, let's see. Here's 50 right here. So I'm just going. So it looks like from here, this is over 50, which means we're coming down here. It looks like at 12 noon, and then it's back at 20, from 12 to 20. All right, now this is telling time. So this is noon, and then 20. If you just subtract 12. That would be 8 o'clock p.m. So from noon to 8 looks like C. From 12 to 8. All right. When was the temperature below 40? All right. So 40 would be right here. So we're looking at below 40, this part right here. And then here's 40 again, this part right here. All right. So we're looking at from midnight. So that's 12 o'clock. Midnight to right here. What is this? 8, 9, that's 10 o'clock. So let's do midnight to 10 o'clock. And then it's back over here. It looks like 21. Right here, 21. So if I do 21 minus 12, that'd be 9 o'clock p.m. to midnight. Now, let's see if I see this on here. From midnight till 10 a.m. and then after 9 p.m. So I think that's C. Okay. All right, let's go to the next one here. The temperature in town B is 7 degrees higher all day long. At what time was the temperature in town B the same as the temperature at noon in town A? Okay. Well, let's first, at noon in town A, here's town A. What was the temperature at noon? So at noon, we're right here at 50, right? 50. So this is 50. All right. So the temperature in town B is 7 degrees higher all day long. So at what time was the temperature in town B the same? What time was it 50 there? Okay. So that means, since it's 7 degrees higher, that means when in town A, when it's 43, that means it would be 50 in town B, right? Because if it's 7 degrees higher, if it's 43, if I add 7, that would make it 50 in town B. This would be A, and this would be B. So we basically want to look at the graph and see when it's 43. So let's see here. When is this 43? So here's 40. 43 would be about right there, wouldn't it? There's 40, 45. So if I come over, looks about like right here at 11 o'clock. And then also over here, that looks like maybe 20 and a half, which if I subtract 12, that'd be 8 and a half. So that's 8, it's like 8:30. So it looks like maybe 11 o'clock and 8:30. Looks like C. Okay. All right, now let's see the last question here. We might have to do some, I'll tell you what here. I'm gonna just, there you go. So we can see this problem here and the graph at the same time. All right, use the graph to give a word description of the 24-hour period in town A. So what word description can we describe for what's going on in town A? So the temperature is just below 40 degrees from midnight to 10 a.m. when it begins to rise until it reaches a maximum of 70 degrees. Well, it don't really hit 70. It's a little bit less than 70. At 4 p.m. All right, now let's see here. At 4 p.m. Yeah, that's probably about right, 4 p.m. Until it reaches, all right, then it begins to fall until it reaches just under 40 degrees again at midnight. Okay, that one does sound pretty good right there. Let's read the next one. The temperature is just below 40 degrees from midnight to 6 a.m. So at 6 a.m., when it begins to rise, well, no, it's not rising because, see, from 6 to 7 it hasn't risen. So I don't think this one's right. A is looking pretty good right now. Okay. Well, it's just A or B. So it's got to be A because that's only two choices. So it's A. All right. So anyway, that was all we have on functions in this lesson. So if you have any questions, please contact me. I'll help you all I can. So have a good rest of the day. Okay? And we'll see you.